Okay, so let's take a look at problems 3 and 4 off of that review. These are kind of fairly straightforward equation-based problems. So on a problem like 3a, I think the thing that I would probably want to do is a fraction buster. So I would choose to multiply each one of these pieces by 12. Every teacher kind of has their own way of doing that, but my style is I usually just multiply everything by, and then I do a little bit of canceling because that was the whole reason why we did it. I don't create that common denominator. I multiply by that common denominator just to make everything look out a little bit better. So if we use our distributive property, that's going to be 2 times 2x minus 1 is 4x minus 2. 3 times 4 minus x would be, 12 minus 3x. And the 12 just cancels, so I got 5. So we're actually good to go on that one. We've taken a very difficult looking problem and we've cut it down a little bit. So it looks like I've got x plus 10 is 5. And we got down to x equals negative 5. Now, I did mention in class that if you want to, you could actually try to plug negative 5 into each one of these things and see if you do, in fact, get 5 12s. And in general, I think that's a really smart thing to do. But I think I'm going to wait till maybe one of the other problems just to do it one time so that I don't need to make the video too long. So on this problem, I'm going to multiply everything by 30. So again, 15 goes into 30 twice, 10 goes into 30 3 times, and 30 goes into 30 exactly once. So if we distribute, we're looking at 12 minus 4x. And this is the reason I asked this question. It actually models what happened on the thing you guys did as a group quiz, that if you multiply this 3, it's really not multiplying 4x, it's actually multiplying negative 4x. And when you multiply this 3, you're not really multiplying negative 1, you're actually multiplying by positive 1. And there we go. So after we put all this together, we've got 15 after we combine like terms. You got 16 x's that are negative and 7. And looks like I move everything across. I got negative 8. And so some simple little answer of 1/2. So a pretty easy little answer. Now, like I said, it might not be a bad idea to go ahead and check that answer. So one of the things that I like to do is I will take something like 0.5 on my calculator and store it as a. Now, again, not that you have a is so easy at 0.5. I'm not worried about that. But if it was 7/15 or something, 2 plus the square root of 3, it could be harder. So I like to do that. So I like to go back to the original problem and do 6 minus 2a over 15 minus parentheses 4a minus 1 over 10. And my question is hopefully I'm going to get 7 over 30. So I got this rather unpleasant looking decimal, but if I had math enter, I got 7/30. That confirms I've done that problem correctly. Morning, Elizabeth. So what we're going to do on this next one, this compound inequality, is we're going to multiply everything through by the number 3. And the reason I put that in there is I want everybody to remember that this 2 right here is also part of that play. So if I multiply everything by 3, the whole reason for that was to take this fraction out. But we also have to remember that all 3 sides get multiplied. So if we keep going just a little bit and we do a little bit of simplification, that doesn't look like a very good 8 there. We're getting closer. Let's subtract 8 from all 3 sides. And our last most significant step is, remember, if you divide by a negative, we want to flip these things. And so I'm going to get 7/3 over here, and I'm going to get 26/3 over here. And so I have all possible values from negative 7/3 to 26/3. It'll just be one moment. Okay, that's right. Got one more question to do. Okay, and then the last one we're going to do is this guy right here. We're going to do our fraction buster, 6 and an 8. Now, you could do 48, but 24 is a little more convenient. So 6 goes into 24 4 times, 8 into 24 3 times, and of course, I got nothing to cancel over here. So we got 12 minus 16y just like the previous question, I'm going to have negative 3 times 2y. And this is really 3 times a double negative, so it's actually a positive 9. This is the part that most people make the mistake on. So again, if you took the time to check your answer, you might find you made a mistake if you forgot to use the distributive property correctly on that portion. So we are going to do a little bit of cleanup. If I move things around a little bit, I got negative 22y, but negative 24, so I could slide it across. Right here, I got 21, and that's going to be greater than or equal to 48. So 2 extra quick little steps, and we got 27 halves. So again, if you wanted to make this an interval notation, instead it would be 27 halves until infinity, and that would be the interval notation portion of that. I was planning on doing 3 and 4, but I think that video is going to be long enough for that since there was actually 4 questions in there. So I'm going to go ahead and stop it there. I'll see you back in class. Bye-bye.